Homework 6, section 3.4, logical arguments, video number 7. I'd like to show you a homework example. I'm going to be on homework 3.4 and look at question number 2 because sometimes the issue isn't how to do the problem, it's how to actually type in the problem. So let me disassemble my studio for a second and we're going to go to the other side here and I'm going to do my best to video doing question number 2 with my left hand while I'm using my right hand to actually do the problem. Now, of course, I'll probably just do this problem exclusively here without going back to the board, but I could. So, using truth tables, determine whether the following argument is valid. We have a biconditional with P and Q on either side as our first premise. For our second premise, we have the negation of Q, and for our conclusion, we have negation of P. Now, knowing what I know about logic, I'm pretty sure this is a valid argument because I know what biconditional means. A biconditional is true when both halves match. But let's see. Part 1, write the argument as an implication. So for the implication, we have to set up, well, I was looking for the double-lined arrow, but I don't see it here. So maybe what I said earlier wasn't true. For the implication, I think you can use the single line arrow instead of the double line arrow. On the right side of the implication is your conclusion. So we need to type the negation of Q, the conclusion is the negation of P. So let's click negation. No, let's click negation and type a P there. Now, the left side of the implication is the conjunction of the premises, and it's going to need to be in parentheses, so we'll go ahead and set up some parentheses. And inside that parentheses, we need a conjunction, so we'll set up this conjunction. And on either side of that conjunction, we need both premises. I'll go ahead and type the second one on the right, negation Q. But on the left side of the conjunction, the first premise is another compound statement. So I'm going to put it in another set of parentheses. Biconditional, P on the left, Q on the right. So this should be the correct answer for the implication since it's not giving me the option to click a double-lined arrow. That really bothers me. Conjunction of the two premises pointing to the conclusion. Let's check it. Hooray! Alternate answer. Oh, look at this. The answer they were expecting did not have the giant set of parentheses around the conjunction of the premises. Silly author. Construct a truth table. Now, if you haven't fiddled with the truth tables in this section, you might have noticed that some truth tables have this option of inserting a column. Frankly, I wish they wouldn't give you the columns as is because they're not in the order I would set them up. For example, if I were setting up the columns, looking back here at my argument that included the extra parentheses, my implication that had the extra parentheses, you would go inside the big parentheses and then go inside the small parentheses and set up a column for the biconditional first, followed by negation Q, followed by conjunction, followed by negation P, followed finally by the implication of the conditional. But if you notice in this one, they have already set up columns for both negations, which actually isn't that uncommon. Go ahead and set up the negations. You'll need to set them up eventually, and then they set up the biconditional. So let's go ahead and knock these out real quick. The negation of the P column is going to be, nope. Change all the values in the first column. So F, okay, I can't press the down arrow to go there. What happens if I press tab? It goes across. I don't want to go to that one yet, okay? False, we're still negating the first column, so false. Oops, go back. Still negating the first column, so true, and then true. Now let's go fill in the negation of Q. The Q column is TFTF, so its negation will be FTFT. So F, T, F, T. And now let's go ahead and fill in the column for the biconditional. And remember, the rule for biconditional is true if both sides match. So I will be looking at these two columns here, P and Q, and asking the question, do they match? If the answer is yes, I put a T. In the first row, they do match, which means the biconditional would be true. In the second row, where's my finger? There it is. In the second row, they don't match, which means the biconditional would be false. In the third row, they don't match, so the biconditional would be false. And in the last row, they do match, so the biconditional would be true. Now, here's where you can take advantage of this insert. We've calculated columns for both negations and the biconditional. Of the remaining symbols, the conjunction and the conditional, the conjunction would happen next. So I'm going to insert a column, and I'm actually going to type what I want in here. I'll have to scroll down a little bit. Give me 1 second. Okay. I want a column representing the conjunction. So let's go ahead and set up the conjunction. On the left side of the conjunction is the biconditional in parentheses. So let's set up the parentheses and write a biconditional. Biconditional. P, Q. And on the right side of the conjunction, we have the negation Q. So let's go ahead and type negation Q there. Negation Q. All right, so let's go through, and as you can see here, this column is not graded. This is just to help you complete the truth table. All right, so we want to do the conjunction of the biconditional and the negation of Q. Here's the column for biconditional. Here's a column for negation of Q. So we're going to use these two columns and do the conjunction rule. The conjunction rule is true if all true. So looking at these two columns here, is there any row where it's all true? Hey, there's one. That's the only row where both are all true. So that's the only row where the conjunction is true. So right here, the conjunction is going to be true. The rest are going to be false. Again, this column is not graded. It's just to help you complete the truth table. Okay, now all we have to do is fill out the column for the conditional, and the rule for conditional is false if T points to F. On the left side of the conditional, and this is why I prefer the parentheses, is this whole conjunction. So the column we just made there. On the right side is the negation of P, which is way over there. So number one, there's a lot of stuff in between the two columns I want to look at, and number two, they're in the wrong order. So I'm going to do myself a favor. I'm going to insert the negation P column here. I don't have to, I already have a negation P column. But when you're evaluating a conditional, it helps if number one, the columns are next to each other, and number two, they're in the correct order. Negation P was false, false, true, true. Don't know what that is. False, false, true, true. And again, this column's not graded. Okay, so now I'm ready to do the column for the conditional, which again, I wish there were giant parentheses around this. We need the giant parentheses pointing to the negation of P. Here's the giant parentheses content. Here's the negation of P. I'm looking for any place where T would point to F. If you'll notice, there's only one T in this column to begin with, and it's not pointing to an F. There is no T pointing to F. So none of these are false, which means all of them are true. True, 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 true. So the hardest part about some of these homework problems is actually getting the table filled out the way they want it. Pretty sure I didn't make a mistake. We'll know in a second. Hooray! Determine the validity of the argument. It's valid or it's invalid. That is 100% dependent on whether the implication was a tautology. This implication is a tautology. It was all true. That means the argument was valid. I highly recommend writing out the truth tables on paper and then going into the homework and completing the columns that they request. It's not impossible to do it entirely within the homework. However, on your test, I am going to ask you to send me pictures of your work, so it will be important to be able to write these tables down.